Today on Tech Talk, we're going to build a Tesla coil that I got from IC Station, and we'll see whether this thing actually produces high voltage like they claim. I received this little bag of parts from IC Station. Little circuit board and some parts. And a set of instructions, all written in Chinese. But, well, what this is a Tesla coil. And basically you can take a sound input and it will drive a Tesla coil and produce high voltage, which they say you'll actually be able to hear music coming from this thing. Interesting. Oh well, let's see if we can build this thing. See if it will do as they claim. Gonna fire up all my soldering equipment here and we'll start putting the parts on this little board and see what happens. Basically what we're doing is we're creating a switch that will induce a high voltage in this coil. And it will add the audio from a music source. So it will modulate the high voltage with music. Operates on 15, looks like 15 volts. Nope. Not, maybe that's 9 to 30. I can't read Chinese. Sorry. I'll have to translate that. Anyway, I think it should be pretty straightforward as to what parts go where, because everything is silkscreened onto the board. So let's begin mounting parts. We'll start out with resistors. There's not many of them here. Looks like I've got just a 10K and a 2K. There's two 10K and two 2K resistors. Yeah, here we go. 2K. Red, black, 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 and a brown. These are the 10K. So we'll mount the 2K resistors first. As I say, there's only two of them. So here's a little fun fact about a Tesla coil. It was invented by Nikola Tesla in 1891, and it's a radio frequency oscillator that drives a double air coil, double tuned resonant transformer. Produces high voltages at low currents. And so the circuit that we're building here is just an oscillator to drive the primary for this air core secondary. I'm curious as to whether this thing's going to produce enough voltage to fire up my plasma ball. I have a plasma ball that the power supply is hooped on, and I might maybe this will produce enough voltage to actually excite the gas in the plasma ball. That'll be interesting to try that. Next is the 10K resistors. And there's a couple capacitors on here. This one's marked 105 and it's marked 105 on the board. So as I say, they're pretty straightforward to assemble a kit like this, especially one that doesn't have a lot of parts. couple of LEDs, and they're marked which way they go. There's a flat side on the LED. Now the flat side is the side with the shorter lead. That's your cathode. So we'll put the two LEDs in place. And what else goes in here? There's a 1 microfarad capacitor, and this one is polarized. Positive lead is to the bottom of the screen here. Long lead goes into one marked with the plus. And what else goes on this? There's not much else left to go on here. There's a neon lamp and the two transistors and the jack, I believe. So the neon lamp itself is actually not part of the circuit. It's actually used to test the presence of high voltage once you've got the kit complete. Just hold it anywhere near the coil itself and it's going to glow bright in the presence of high voltage. So that's all the neon lamp is for. What I see is the primary of the transformer is going to go here, L1, across here, and we're going to take this wire and we're going to wrap this around the main coil. There's an inducer, this is the secondary, and that will produce the high voltage. So I'm just waiting for my hot glue gun to heat up, and then I'm going to mount the high voltage coil onto here and connect one lead to it to the ground, and then we'll take the other wire here. We're going to wrap about 3 turns around. It says 2 to 3 turns. That's what this 2-3T means. We're going to wrap that wire around here and then put the 2 transistors in, the audio jack and the power jack, and we'll plug this thing in and see whether we can draw some arcs, and I'll find something to play music through this thing to see if we actually can hear any music. I don't want to have my phone or anything around here, anything electronic that could be zapped by ultra high voltage. I'm going to keep away from this thing for sure. Just waiting for the glue gun to heat up here so I can put some hot glue around the bottom of the unit. It's not quite hot enough yet. We'll glue the coil in place, then mount the remaining parts. I guess I can probably mount the remaining parts while I'm killing time here. But let's mount some standoffs on this thing while I'm waiting for my glue gun to warm up. We'll mount the 2 transistors onto the appropriate heatsink. I'm not bothering with heatsink compound either, because even though it's going to get hot, these are going to be fine. Screwed right down to the aluminum heatsink here. It should transfer the heat just fine. Okay, we just have to identify which is which. This one here is the tip 41C. So the tip 41C is going to go right through here like that. And the other one is going to go, this is the IRF 530, and it's going to go just like that. So I'll mount those two, solder those two down. We have a power jack to go on here. And we can actually apply power directly to the board if desired. But I'm sure I can probably find an adapter that will power this thing up just fine. Standard tip positive, looks like. Audio jack is the last part to be mounted to the board. And then the big coil and the primary winding. And that is going to be it. Then we can test this thing. See whether it does what it's supposed to. Okay, now I should be able to mount the coil. Some hot glue on here. And stick down the coil. Now we'll connect. I'm just going to get my magnifiers here so I can see this very fine wire a little easier. We're going to take the wire and thread it down. Solder that one down. Now we have to make up the primary coil, which is made up with the solid wire. We'll do 2 to 3 turns, it says, and that should be more than sufficient. One, two, about 3 turns there. So now what this does is this creates a large current that's going to go through the primary winding here, which is basically just the green solid wire, which Just going to solder that down here to the board. Do our 3 turns. And then the other side goes down into this last hole. And basically what we're doing is we're making a small flyback type transformer. Okay, we're ready for testing. Okay, for the initial test, I'm going to shut off some lights here. I'm going to power this thing up with a battery. So I've got my negative terminal going right to the negative terminal on the DC jack, and I've got my positive terminal going to here. I've shut the lights down, and I've got 2 lights on here, which I shouldn't have, but we got high voltage. If I bring the neon lamp near, you can see that we are generating high voltage. But nothing like we're supposed to be. Oh, there's a little bit of a spark there. I should be generating a much higher voltage than I am. Tesla coil won't generate enough power to give you a shock, but you can certainly see it stings. And you can smell it burning on your fingers when you touch it. Smells like burning hair. That's actually my skin. The voltage coming off this thing is exceptionally high voltage, and stinks. I got some little black pinpoint marks on my hand here. I don't know if you guys can see it or not, but right there, from touching this thing. Yeah, that's got a bit of a bite to it. Okay, so I've actually plugged a music source into this thing now. I don't know if we're going to hear anything, but I'm going to just take an old dead fluorescent bulb and hold it near the coil, and we'll see if this thing lights up. Oh yes. That's pretty cool. I don't even have to touch the wire. I just have to bring it close. This thing's generating, thousands upon thousands of volts. If I hang onto the glass, now I'm only giving this thing 12 volts, so I'm not even giving it full power. I think it says the input voltage is 15 to 24 volts. Let's give it another battery. We'll give it 24 volts and see what it does. Okay, now I have 2 batteries that I'm going to connect in series. Oh! Now we've got some serious voltage happening here. It's stuck to the glass. The wire has welded itself. Look at this. The wire has welded itself to the glass. I can drag it around. it welded. Oh, man, the glass got hot there too. I bet you if I left it long enough, that would have melted the glass, and this lamp would have gassed out. Now, I should be modulating this thing, even if I hold this near the coil. So that's it. This little Tesla coil actually does work. And what I would be curious to see is, I have an old plasma ball, and if I put this inside the plasma ball, is it going to light the plasma ball up? I bet that it would. Because as you can see, I don't even have to touch it. I just get close with the lamp, and this thing's lighting up. And I say this is a dead lamp, but I wonder if I arc this enough, will I actually break the lamp? Will I make the lamp outgas? Or did I just weld it? I think I just weld. Oh, we did it! We did it! I got the lamp, I got the bulb so hot, the glass, I actually burned a hole. You can see it. I actually burned a hole in the glass. I got the glass so hot from that RF that it actually melted the glass. Cracked it right there. Cool. This was a dead lamp anyway, but now I just let mercury into the environment. Bad. Cool, huh? Okay, that's my little Tesla coil there that, as you can see, generates plenty of power. And don't stick your fingers near it. Well, it won't hurt you. It won't electrocute you or anything, but as you can see, it's making this neon lamp glow really bright. This will light up neon. Hey, let me go grab my other neon. I got a neon sign here. Let's see how it lights it up. I'll go grab my big neon and see what it does. Will it light this thing up? I bet it will. I bet it will light this up. Here we go. Without even touching the wire. If I touch the electrode, it'll light up for sure. Oh, I thought it would, but it lights up the glass itself. I don't want to burn. I don't want to break my lamp though. I'm not going to damage that one. Now here's something. Listen. I'm just taking an ordinary light bulb. Listen. You'll hear music. I've got music playing from my radio. You'll hear it. Okay. Well, that's kind of cool. That's very cool. This is a burned out filament bulb. I heard music a minute ago. I don't know why I'm not hearing it now. There, you can hear it. in that noise. You can hear music playing. Cool. Look at that. Isn't that neat? Inside that bulb, off the end of the wire there. Wonder what happens if I use an old halogen bulb. What will it do? Will it light up too? Yes, it will. Cool. I wonder what a mercury bulb will do. I got music off this when I first plugged the power on before it settled in. Whoop. That's very cool. Very cool. Wonder what it will do with this big 400 watt metal halide lamp. Probably nothing. Oh, yeah, it does. It's making the arc tube glow. Interesting. It's actually the globe is getting warm. Right where the arc is going towards my finger, the glass is getting warm over there. That's pretty cool. Very cool. Now remember, no matter how much you push the envelope, it's still stationary. Thanks for watching, and we'll catch you again in the next one real soon.